Hi everyone, and welcome to this video on AM demodulation using the Hilbert Transform in MATLAB. We'll walk through each step of the code, explaining how amplitude modulation works and how we can demodulate the signal using the analytic signal technique. Next, we define our key parameters. Fs is the sampling frequency, set to 10,000 Hz. T is the time vector running from 0 to 10 milliseconds. Fc is the carrier frequency, set to 1000 Hz. Fm is the message frequency, set to 100 Hz. AM and AC are the amplitudes of the message and carrier signals, both set to 1. And mod index is the modulation index, set to 0.8, which controls the depth of modulation. Now, we create the message signal, which is a simple cosine wave. This is our baseband signal that we want to transmit. Using this message, we construct the AM modulated signal. Here, we're modulating the carrier by varying its amplitude according to the message signal. Now comes the core of the demodulation process. We compute the Hilbert transform of the modulated signal using MATLAB's Hilbert function. This gives us the analytic signal, a complex signal that helps extract the envelope of the original signal. Next, we find the envelope by taking the absolute value of the analytic signal. This envelope represents the demodulated version of our message signal, but it still includes a DC offset. To remove the offset, we normalize the demodulated signal by subtracting its mean. This gives us a cleaner version of the original message signal. Finally, we plot the signals in 4 subplots. The original message signal, the AM modulated signal, the envelope obtained via the Hilbert transform, and the final demodulated signal. These plots visually demonstrate how the signal transforms at each step. This is your baseband signal, a simple cosine wave with a frequency of 100 Hz. It's what we want to transmit and later recover through the demodulation process. As expected, it smoothly oscillates between -1 and 1 over the 10 millisecond time span. This plot shows the result of amplitude modulation. Notice how the high-frequency carrier, 1000 Hz, varies in amplitude according to the shape of the message signal. This variation in amplitude is how the message gets embedded onto the carrier wave. Here's where the Hilbert transform comes into play. This plot displays the envelope of the modulated signal. In other words, the outline that traces the upper boundary of the AM wave. You can clearly see that this envelope matches the original message signal shape. Finally, this is the result after normalizing the envelope. We've successfully performed AM demodulation using the Hilbert transform. If you found this helpful, don't forget to like, comment, and subscribe for more signal processing tutorials. Thanks for watching.